Hello and welcome back to MetaMath. In this video I'm going to be covering problem 25 on the AMC8 2019 exam. The problem reads as following. Alice has 24 apples. In how many ways can she share them with Becky and Chris so that each of the people has at least 2 apples? So the problem is placing a restraint on the ways we can distribute the apples, and each person has to receive a minimum of 2 apples. And we're also dealing with apples. Alice has 24 of them, so we can assume that they're indistinguishable, meaning that Alice and the other people won't be able to tell one apple apart from the other. Using this fact, we can satisfy the constraint because every way we distribute the apples is unique without the apples mattering. So if we give Alice 2 apples right off the bat, Becky 2 as well, and Chris another 2, we've already satisfied the constraints. But we're not done quite yet with the problem because we have 24 apples and we have to distribute them all. We've only used up 6, so we still have 18 apples left to work with. But because we've satisfied the constraint, however we distribute the 18 apples is not important because we've already met the constraint. So now the problem boils down to 18 apples which we have to distribute among 3 people. Because however we distribute these 18 people, we create a unique solution that satisfies the original problem because we've already satisfied the criteria. So to think about this algebraically and more concretely, let's say the number of apples Alice has from these 18 is A. Let B represent the number of apples Becky will get, and let C represent the number of apples Chris will get. We want all of these to sum to 18, so the combined apples Alice, Becky, and Chris will have should be at least, or has to total to 18 here. So to do this, or to solve this, we can use a technique called stars and bars. And for all of these variables, we have to use the condition that they're obviously greater than or equal to 0 because we can't have negative apples here. So to do this, we use a technique called stars and bars. So the stars in this case would be our apples. So we have 18 apples, and we have 2 bars. Now what the bars represent are, they act as dividers. So if we placed bars here, we essentially create 3 groups because we have the 3 people. So group 1 is everything to the left of the first bar, which could be Alice. Group 2 is what's between the 2 bars, which is Becky in this case. And group 3 is what's to the right. And how stars and bars works is it creates solutions to this equation. So we're solving only in terms of integer values. So the unique solution that we just obtained is that A is 2, B is 1, and C is 15. And this satisfies the original equation we're working with, and that would give us a final value of Alice having a total of 4, Becky having a total of 3 apples, and Chris having a total of 17. So with this final value, we've satisfied not only the constraint, but we used all 25 of the apples. So to use stars and bars here, we have to figure out how we're going to distribute the 2 bars among the 18 apples. So to do this, we have a total of 20 choose 2 ways because we have 20 items and we want to pick or place the 2 bars between them. So in general, however, we can represent this by using the fact that if we have n items and we have k groups we want to sort them into, and the n items are indistinguishable, as in the case of the apple we won't be able to tell them apart, we can do this in n plus k minus 1 choose k minus 1 ways. So another way, if you want to think about this more practically, is before we place any of the bars down, we have 19 possible locations for the bar. So we can place the bar before the first apple, between the first and second apple, between the second and third apple, and so on until we get to the last apple and then the spot after that apple. So because there's 18 apples and each spot to the left has a place for a bar, and the spot to the right has a place for the bar. We have a total of 19 locations for the first bar. Once we place the first bar, which we can arbitrarily place at the first spot, we have a total of 20 spots for the next one. Because when we place the first bar down, we create a new spot to the either left or right, we can place the bar anywhere we could have placed it originally, but we can also place it adjacent to the first bar. So we have a total of 19 times 20 ways. However, this 19 times 20 overcounts by a factor of 2 because the two bars are indistinguishable. And if we place the first bar here and the second bar here, that's the same as placing the bars in the switched position. So we have to divide by 2 here. And notice these two things are equivalent. So we've confirmed that this holds true not just algebraically, but also just by thinking about it. So to solve this problem, we just have to calculate 19 times 20 divided by 2. So 380 divided by 2 is simply 190, which gives us our answer above. And we have solved the problem. So the answer is C, 190, and we got that by using a stars and bar technique. Thank you for watching. If you found this video helpful or enjoyed it, please like the video and subscribe.